Hello, my name is Bob and I'm a tutor at Raritan Valley Community College's Academic Support Center. This is session 4 on GeoGebra and this is module 7 on functional transformations. In this module we're going to explore functional transformations using sliders. We're going to look at vertical shifts, horizontal shifts, vertical stretches, and horizontal stretches. And we'll do that looking at two different functions. First we'll start with the absolute value function and then we'll look at the square root function. So let's get started. And the first thing we're going to do is go over and double click on our GeoGebra icon and load GeoGebra up from the web. And now that we have it loaded, in order to see better, we're going to go to Options, down here to Font Size, and we're going to go to the 18-point font, and that'll make it a little easier to see what's going on our screen. So let's look at the absolute value function. We're going to put in y equals ABS for absolute value of x, closing parentheses, and hit enter. And we can see the typical V-shaped curve that we look for absolute value. Well, now we can put in some constants around that, and we looked at sliders before, and we can put in the constants. Let's put in A, B, C, and D. So let's get started. We're going to set A equals, we'll use 0. We'll use capital B equals 0, capital C equals 0, and capital D equals 0. So now that we've predefined those constants, let's go in and redefine our absolute value equation. I'm going to right click on it. I'm going to go down here to redefine, and I want this to be capital A times, and I'm just going to use implicit multiplication, space, capital B times X with a space, space plus capital C, and then outside the parentheses plus D, and hit enter. And our curve dropped away. Well, if you think of it, look at this equation. It's 0 times the absolute value of 0x plus 0 equals 0. And so we want different values for A, B, and C. Let's go turn our sliders on and we'll get started from there. Going up to A first, right-clicking on it, and then hit Show Object. Right-clicking on B, Show Object. Right-click on C, Show Object. Right-click on D, Show Object. And let's change A and B equal to 1. So I'm going to move this out to 1. And I'm going to move B out to 1. And there's our typical curve, as you would expect to see a curve. So now let's see what happens as we change each of these values. Well, if we move A, you can see that what happens is as A gets smaller, this gets wider. And as A gets bigger, it gets much narrower. What we're doing is a vertical stretch. All right, let's put A back to 1. I'm going to drag it over there as 1. Now let's move B. Okay, and as B gets bigger, all right, we're doing a horizontal squeeze. And as B gets smaller, we're doing a horizontal stretch. Let's take B back to 1. Let's move C. You can see as C goes positive, the curve shifts to the left. Exactly the opposite of what you might think. Take it back to 0, and as D goes positive, it shifts up and down. So we're able to do functional transformations by changing the different values of A, B, C, and D. Now I said that we had a vertical stretch this way when we changed A. We had a horizontal squeeze this way, but they both look the same. Let's take a look and see if we can make it a little clearer. Let's put a point on that curve. And I'm going to define the point x sub 1, x underscore 1 equals 1. And I'm going to define y underscore 1, y sub 1 equals, and I'm going to define it as f of x sub 1. And I've got my y value here. Now let me define the point P equals to x underscore 1 comma y underscore 1, closing parentheses, enter. And there's that point out here on our curve, our absolute value curve. Now let's see what happens when we do our vertical stretch. When we do our vertical stretch, notice that the point P moves higher and higher. All right? Same thing happens with our horizontal stretch. The point P stays on the axis at 1, and we go back and forth. Let's try this with one other curve. And we talked about doing this with a square root function. So let's go back and we're going to get a new file. File, new. No, we don't want to save this one. And let's make it y equals, we're going to have capital A times SQRT of capital B X plus capital C, closing parentheses, plus D. We'll make that capital D. And when I hit enter, notice that our variables were undefined. In GeoGebra, these variables have to be defined before you can use them. So let's delete this. Click OK. We're going to get rid of this. And we're going to go in and define those variables. We'll set A equal to 1. We'll set B equal to 1. We'll set C equal to 0. We'll set D equal to 0. And now we'll put in that same equation. And I copied it and saved it from before, so I put it in there. And now when I hit enter, there's our square root curve. Well, let's go up here and turn these sliders on. Right-click on A and then Show Object. Right-click on B. Show Object. Right-click on C. Show Object. Right-click on D. Show Object. And now, once again, if I move A, I get a vertical stretch. If I move B, I get a horizontal stretch. If I move C to the right, the curve moves to the left. If I move D, it moves up and down. So we've taken a look at functional transformations using sliders. We've seen that vertical shifts happen when the D, which is outside the parentheses, is moved left and right. We found the horizontal shift when the C inside the parentheses is moved left and right, and it moves counterintuitive to what you would think. We found that a vertical stretch happens when you move A left and right, and that a horizontal stretch happens when you move B left and right. This concludes our session on functional transformations.